purpose of this video is to review the concepts related to endothermic and exothermic reactions. So let's review first of all the first parts of these words. So endo very much sounds like in, which is what happens. Energy goes in to the reactants. That energy is then stored as potential energy. All right, exo sounds much like exit. You might have also heard the term exoskeleton. It means the skeleton is on the outside. So in this case, energy exits or goes out. Okay, so how does this look? How does this feel? So you might have been able to experience before a cold pack or a hot pack. So cold packs are actually examples of endothermic reaction. What happens is you have your little pack, and usually it has some sort of little like metal button or catalyst that you kind of snap, and it makes the whole thing get really cold. Why does it get cold? Well, it gets cold because the reactants absorb energy. In this case, it's kinetic energy from the outside surroundings. And it then stores that energy into the products. So the products now have greater potential energy than the reactants do. So the products' potential energy is greater than the reactants' potential energy. So once again, what happens? The reactants, they are going to absorb energy. In this case, it's kinetic energy from the surroundings. Because the energy is being absorbed, the surroundings then feel cold. And as a result, that energy is stored in the products. So the products now have a lot of potential energy. So we see products having more potential energy than the reactants' potential energy. Exothermic reactions happen just the opposite way. So this is what we call a hot pack. So maybe if you go skiing or snowboarding, you've got one of these little packs that you put into your boots or whatever it may be. So there's also a little button or catalyst that you snap or press, or maybe there's two different liquids that you break the seal between and the reactants come together. And what happens is it feels hot. It feels hot because energy is coming out of the reaction. So right here, energy went in. See, it's going in. Here, the energy is going out. So it feels hot because of that. So what happens exactly? Well, the reactants, they break their bonds and they form new ones, and this results in a release of energy and a release of new substances called products. Okay, so this energy that's being released is usually in the form of kinetic energy. It can also be in the form of light, like when magnesium, if you burn it, do you remember you got that big bright light? So that energy could be in the form of light, or it could be in the form of heat. Okay, so in this case, we're going to see that the reactants, oops, that's not what I meant. The reactants' potential energy, it was greater, so the reactants had a lot of potential energy. It's greater than the PE, or the potential energy of the products. Okay, so one more time, we have our reactants. They have a lot of potential energy. They break bonds and form new ones, and it releases kinetic energy. And new products are formed that have less potential energy because of this energy that was lost. Okay, so now that we've talked about what exactly is happening in an endo or exothermic reaction, let's talk about some examples of endo and exothermic reactions. So anytime that there's going to be a flame or heat released, you know it's going to be exothermic. An endothermic is if it feels cold. You know it's going to be endothermic. Okay, so that's some observations you can make. If you do a reaction and it feels warm, you'll know that it's exothermic. If you do a reaction and it feels cold, then that's when you know that it's going to be endothermic. Some ones that are a little less intuitive have to do with phase changes. So when you're going from a solid to a liquid to a gas, you're absorbing energy, right? When you take ice and you add energy to it, it will melt and it'll turn into a liquid. And then if you add more energy to it, it'll turn into a gas. Okay, so this is an endothermic process because energy is being added and it is being absorbed. So anytime energy is added continuously. So a lot of times if you just start a flame, you might just spark a match and then it burns on its own. So that would be an exothermic reaction. But if you're continually having to add energy, it's a continual process, then you know that it's endothermic. Like in order to melt ice, you have to continually add energy to it. Or to boil water, if you turn off that flame, it's not going to be boiling anymore. It's going to cool back down. So if there's continual energy added, then it's going to be endothermic. Exothermic is the opposite. It's when energy is being released. So gas cools off or it releases energy to become a liquid, which then releases more energy to become a solid. So those are going to be exothermic. So let's just review these terms. To go from a solid to a liquid, that's usually called melting. To go from a liquid to a gas, we usually call that boiling. To go from a gas to a liquid, that's called condensing. And to go from a liquid to a solid, we usually call that freezing. Now, sometimes you might have seen carbon dioxide go straight from a solid to a gas. And that's a new term. To go straight from a solid to a gas, we call that sublimation. That's also an endothermic reaction because it's absorbing energy from the surroundings to go straight from a solid to a gas. Okay, now that we've done some examples, we're going to draw them in the form of a diagram. So you've seen these potential energy diagrams before perhaps, so let's put some meaning to them. So here is an example for endothermic, and here's for exothermic. So for endothermic, you're always going to require potential energy, and same for exothermic. They're both going to be on the y-axis, and those units are the standard units for energy, which are joules. Okay. Then on the x-axis, we have reaction progress. So I usually generally abbreviate reaction with RXN. You can do the same. Although if you're writing a paragraph, make sure you write out the full term. So reaction progress. So that just means that as we go to the right, that means the reaction is continuing from start to end. Potential energy also it's going from low to high. Okay, so for endothermic, remember we said that energy is being absorbed. So the reactants actually have less potential energy than the products. Okay, so in order to make the reaction go, it requires a lot of energy to get an endothermic reaction started. And we call that energy of activation or activation energy. It's an E with a little subscript A. Then afterwards, to measure the difference between the energy of the reactants and the products, we're talking about potential energy, remember? So the difference between the potential energy of the reactants and products, do you remember what that term is called? It's the enthalpy or the delta H. And in this case, it's going to be a positive number because the potential energy is going up. Okay, so when we're drawing this for exothermic, it's going to be the reverse. The reactants actually have more potential energy than the products. And it actually only requires a little bit of activation energy usually. This might be a spark or maybe a match flame, something like that, just to get it started. Like when you use your flint strikers in chemistry, those sparks that you make, those are enough to get most exothermic reactions going, particularly the combustion ones. So we're also going to measure the difference in energy between the reactants and products. That's the delta H. And because the potential energy goes down, it's going to be a negative number. Okay, so those are all the things you need to label for these diagrams for an endothermic and an exothermic reaction. So just to review, you need to label the activation energy. It always goes from the reactants all the way up to the top of that little curve. Reactants all the way up to the top of the curve. The difference between the reactants and products, that's the delta H. Reactants and products, that's the delta H, whether it's positive or negative. So because here it goes up, that's positive. Because here it goes down, that's negative. And don't forget your axes. Potential energy and reaction progress are important for those axes. All right, so I think you're ready to practice on your own. So there should be a worksheet for you to do. Please watch this video again if you need practice with the vocabulary again, particularly when you're supposed to be writing a paragraph about something.